Let's look at the first part of the final exam review. So in this first problem here, f of x equals square root x is our parent function, and we want to write an equation for this graph here that's in gray. So before we write that equation, let's take a quick look at the parent function and what its graph would look like. So if I plug in 0 for x, I get 0 because the square root of 0 is 0. If I plug in 1, I get 1 because the square root of 1 is 1. And if I plug in 4, I get 2 because the square root of 4 is 2. I chose not to plug in 2 or 3 because I wouldn't get a nice pretty point. So if I graph the parent function, it looks like this. Notice that my graph starts at 0, 0 and doesn't extend to the left of that. That's because if I would attempt to plug in a negative number, I would not get a real number. The square root of -1 is I. It's not a real number. Sorry, that's supposed to be like a little frowny face there. So the domain of our parent function is x is greater than or equal to 0. So we do not want to extend our graph to the left of the point 0, 0. Now the graph that's given to us, it appears that the parent function has been shifted up 3. So I can see, the point 0, 0, it moved up right here to 0, 3. And if you check the other points, they all shifted up 3. So to write an equation, it's going to be y equals, the only reason why I'm using y and not function notation is because that's what WebAssign does for this problem. So y equals up 3, I am going to put a plus 3 in the back behind, not under, the grouping symbol, which is a square root. So back here, this is a vertical shift up or down. We add if we want to go up, and we subtract if we want to go down. So y equals square root x plus 3 would be the equation of the graph in gray. Okay, part B, we are using the same parent function. So 0, 0, 1, 1, 4, 2. And this time it looks like we've gone left 2 and down 1. So I just noticed that the point 0, 0 has moved down here. So to go from 0, 0 to this point, it's left 2, down 1. Now if you want to check the other points, they also move left 2, down 1. So y equals square root of, now this time we have a horizontal shift to the left. To represent that, underneath the square root, we need x plus 2. I know this is weird because we went left. I always tell my students this is counterintuitive. Okay, so we actually do x plus 2 even though we went left. Now the up or down I feel like is intuitive. I'm going to put a -1 in the back there in order to go down 1. Number 2 is very similar to number 1, but we have a different parent function. So now we're looking at f of x equals absolute value x. Let's make a t-chart for this one. If I plug in 0, I get 0 because the absolute value of 0 is 0. If I plug in 1, I get 1 because the absolute value of 1 is 1. If I plug in 2, I get 2 because the absolute value of 2 is 2. Now, unlike the last problem, I can plug in negative numbers. The absolute value of -1 is 1, and the absolute value of -2 is 2. So the shape of this parent function is a V. This is a V-shaped graph. Sorry, these are supposed to be straight lines. It's just, ooh, okay. Oh, you know what? I think I plotted that point wrong anyway. So, sorry, that was not quite at -1, 1. Here we go. Here's -1, 1. Okay, so our graph here that is in gray, it has been shifted right 4. But there is also a reflection that has occurred. It has been reflected over the x-axis. Instead of being a V-shaped, it's an upside down V. So, ready to write the equation here. Right 4 means inside the grouping symbol, which in this case is absolute value bars. This is the counterintuitive one. I'm actually going to write x minus 4 inside the bars. Okay, and since we have a different parent function, I don't want to use a square root symbol here. I want to use absolute value bars. For the reflection, we put a negative sign in front of the grouping symbol. That's what will reflect the graph about the x-axis. All right, last one like this, same parent function. Okay, so remember our parent function was 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. We got a V-shaped graph. Oh, goodness. So hard to make straight lines using this pen here. That's not too bad. So the gray graph, it looks like it's been shifted left 2 and up 5. Okay, and I'm really just looking at the point 0, 0 and seeing that it moves here. Now you could check all 5 points, but they are all moving left 2 and up 5. So for my equation, okay, here are my absolute value bars. Left 2, this is the one that's counterintuitive. I'm actually going to do x plus 2 inside the bars. The up and down I would say is intuitive. Up, I'm going to add. If it were down, I would subtract. But this would be my new equation because the graph has been shifted left 2 and up 5. Okay, and number 3, we are asked to write this quadratic function in what we call vertex form. So the form a times the quantity x minus h squared plus k. So first thing we're going to do is let's get rid of that 7. Not get rid of it, I guess. Move it to the other side just to get it out of the way. The next thing we're going to do is we're going to factor out a from the right-hand side. Now, you may notice that I could also pull out an x, but I do not want to do that. we're gonna create a perfect square trinomial. And so I need the x squared and I need the x in that second term there. So only pull out just the leading coefficient. All right, now we are going to complete the square. Sorry, before I do that, I just want to mention that the second term was a negative 30x, but don't forget when you pull out a negative 5, it does change that to a positive 6x. So students sometimes will mess up that sign there, so just be careful. Okay, so to complete the square, we take the b, or in other words, the coefficient of x. We divide it by 2 and square the result. That's how we complete the square. 6 squared is, sorry, not 6 squared, 6 divided by 2 is 3, and 3 squared is 9. So I am going to add 9 inside the parentheses to create a perfect square trinomial. Now I'm going to leave a space over here because I'm going to have to balance things out. I want to make sure that whatever I do to the right-hand side, I also do to the left. Okay, so I made that in blue there so it stands out. So I added 9. Now you may think, okay, I added 9 to the right-hand side, so I should add 9 to the left-hand side. Well, yes, we did add 9, but we put it inside parentheses, and there's a multiplier in front. So the effect that has on the right-hand side is not actually 9. It's actually an effect of adding a negative 45 or subtracting 45, same thing. So you're going to have to distribute the multiplier in front to see what effect that has on the right-hand side. So to balance things out, I actually had to subtract 45 from the left-hand side. 7 minus 45 would be a negative 38. And then over here on the right, I am able to factor x squared plus 6x plus 9 as x plus 3 quantity squared. Down a little bit. There's just one more step. I need to add the 38 to both sides to isolate f of x. And so my equation is f of x equals negative 5 times the quantity x plus 3 squared plus 38. So this is the quadratic function in vertex form. Now, if you had time, you could check your answer. If you expand x plus 3 squared and then distribute a negative 5 and then add 38, you would be back to the original equation. All right, let's take a look at this next one here. So it says an object is projected vertically upward from the top of a building with an initial velocity of 112 feet per second. Its distance s of t in feet above the ground after t seconds is given by that equation. So we want to know, when will the object reach its maximum height and what is the maximum height? So here's my building here. And so you've got this object that is being projected. And so we want to know, when will the object reach its maximum height and what is the maximum height? So we basically need to know the coordinates of this top point here. And this top point here is just the vertex. So to find when it's going to reach its maximum height, we just need to find the x coordinate of the vertex, which I guess it's the t coordinate since they've used t instead of x. So to calculate t for the highest point, we have a formula, and that is negative b over 2a, where the a and the b that I'm referring to are the coefficients of the t squared and the t. So our b is 112. So here's this is our b, this is our a. So negative b would be negative 112. And then 2 times a would be 2 times negative 16. So we have negative 112 over negative 32. And this is, let's see, use my calculator, 3.5. So the object will reach its max height after 3.5 seconds. Now, you don't have to worry about the unit of time for this exam, because in WebAssign, the only thing you would have to enter would be 3.5. What is the maximum height? So all we have to do for this is just plug 3.5 into the equation for t. So we just have to find s of 3.5, and this will give us our maximum height in feet. So negative 16 times 3.5 quantity squared plus 112 times 3.5 plus 90. And this will give us our maximum height. So I'm going to use my calculator here, type all this in, and I'm getting 286 feet. All right, number 5. So number 5's a pretty long one. It's going to take us a while. We got to give ourselves lots of room here. I'll start there, but I know I'm going to need even more room. So we have these two rational functions, and we want to add them, subtract them, multiply them, and divide them, as well as state the domains for those functions. Starting with f plus g of x. Sorry, I should have written that first. We're just going to start with that. So I'm going to take f of x plus g of x. To add these, I do need a common denominator. So I'm going to multiply the first fraction here by x plus 4, top and bottom, and the second one by x minus 2, top and bottom. I eventually will distribute, but for now, I'm going to go ahead and just add numerators and retain my common denominator. Now let me go ahead and distribute. So in the numerator, I'm going to distribute the x, distribute the 3x, so we have x squared plus 4x plus 3x squared minus 6x all over x minus 2 times the quantity x plus 4. And then combining like terms, I have 4x squared minus 2x, and then all over x minus 2 times the quantity x plus 4. Now, if you want to factor out a 2x from the numerator, you can, but it will not help to reduce this at all. So it is not necessary unless you really want to. Now it's also going to ask for the domain on the exam. So for the domain, we have to look at the intersection of the domains of f and g. So the domain of f is that x minus 2 cannot equal 0. This is because division by 0 is undefined. So the domain of f is that x cannot be 2. The domain of g is that x cannot be negative 4. So our domain is x cannot be 2 or negative 4. You could also look at f plus g. Look over here at this function to come up with the domain. Now just be careful because sometimes, especially with division, when we get to that, if you look at just your final answer, you're not going to get the correct domain. In WebAssign, they have kind of a really weird way to write the domain. So let me bring that up because you're going to need this for the exam. So in WebAssign, they will write this. This means the set of all real numbers, but remove from that set the numbers negative 4 and 2. So they're basically saying the domain is all real numbers except negative 4 and 2, which is really the way we've written it as well, but that's just how they write it in WebAssign. So you'll want to be familiar with that notation. All right, now let's do f minus g. So this time I'm going to write f minus g of x. So this is where we take f of x and subtract g of x. And once again, we need a common denominator. So I'm going to go ahead and jump to, I'm going to use this over here, but in place of where I have my plus sign, I'm going to use subtraction since we're subtracting this time. So I'm just going to kind of copy from there because it would be the same common denominator as what I used when I was adding. So we're going to have x times the quantity x plus 4 minus 3x times the quantity x minus 2 all over our common denominator. This down here. So our common denominator is x minus 2 times the quantity x plus 4. And I'll go ahead and distribute to get x squared plus 4x minus 3x squared plus 6x all over my common denominator. And I'll combine like terms to get negative 2x squared plus 10x all over x minus 2 times the quantity x plus 4. The domain here is the same domain as f plus g. So I'm just going to write same domain. Until we get to f divided by g, we're going to have the same domain. All right, let's now look at f times g. This is such a big problem, isn't it? So multiplication is actually the quickest of all of the operations. So we're going to take f, which was x over x minus 2, and multiply times g, which I can't remember, 3x over x plus 4 is what it was. So 3x over x plus 4. We do not need a common denominator when multiplying. We just multiply the numerators together and we multiply the denominators. All right, so this is our answer. And it also has the same domain as the first two. So same domain. Okay, finally, f divided by g. So we're going to take f and divide by g. I'm going to write it like this first. So, but we know that this is the same thing as saying this. And we know it's the same thing as then multiplying by the reciprocal of the second fraction, which in this case is the function g. We do want to simplify, and the one thing that we can do to simplify is we can cross-cancel an x. Okay, so we're going to want to simplify. So simplified function here would be x plus 4 over 3 times the quantity x minus 2. So when I multiply the 3 and the x minus 2, I've chosen to leave it in factored form. If you want to distribute, you can, but it is not necessary. Okay, let's look at the domain. So the domain of f divided by g, if we look at our final answer, we're not going to get the correct domain. So we are supposed to look at the intersection of the domain of f, the domain of g, and we also have to make sure that we remove any number or numbers that would give us g of x equals 0. So I'll explain here in just a second, but we still have to say that x minus 2 cannot be 0. So x cannot be 2 because 2 would make this denominator here 0. Okay, so I'm looking at my unsimplified answer to come up with the domain, and I see x cannot be 2 because 2 minus 2 is 0, and my numerator would be undefined. Okay, I also need to make sure that x plus 4 does not equal 0. So x cannot equal -4, because if x is -4, then my denominator would be undefined because I would be dividing by 0. So that's why -4 needs to be removed. Oops, now I lost my x. But there's also a third number that we want to remove from the set of all real numbers when we're stating the domain. And to find that third number, we set the entire function g of x not equal to 0. Because we don't want this entire denominator to be 0. So we have to make sure that we're never dividing by 0. So we don't want the entire thing to be 0 either. Okay, so to figure this out, I could multiply both sides of the equation by x plus 4. And when you multiply 0 times x plus 4, you still just get 0. And then I could divide both sides by 3, and I'm still going to get 0. So the domain for this one is, in WebAssign, this is what it's going to look like. All real numbers minus the set containing -4, 0, and 2. So I have to remove all 3 of these numbers from the set of all real numbers. Okay, that one was fun. Let's look at number 6 now. This is also kind of a big one here, so gotta give myself lots of room. Move this down. So we are now looking at a couple of composite functions. So f circle g is also known as f of g of x. So this means we're going to plug the function g into f, okay, and we're going to plug it in for both x's. So this is going to be 6 over x over 6 over x plus 3. Then we're going to go the other direction here in just a second. The quickest way to simplify this would be to multiply both the numerator and the denominator by x. And don't forget to distribute in the denominator. This will get rid of our complex fraction and we'll just have a normal fraction. So in the numerator, when you take 6 over x and you multiply times x, the x's will cancel and you just get 6. In the denominator, when you take 6 over x and multiply times x, the x cancels. X's cancel, we just get 6 again. But we also need to distribute the x to the 3, and we'll get 3x. Now, the last thing I want to do before I report my answer is I do want to reduce. All 3 terms of this fraction are divisible by 3. So I could divide everything by 3. Okay, so final answer then is 2 over 2 plus x. Okay, or, I mean, that's completely fine. But if you also want to make the denominator x plus 2, that's okay, same thing. So either one is fine. For the domain, what we have to do for the domain is we have to find the domain of the inside function and also find the domain of the newly created composite function. So the domain of the inside function is the domain of g. So the domain of g of x is that x cannot equal 0. Because if you look up here at the function g, we have x in the denominator, and so we do not want x to be 0 because division by 0 is undefined. Then we have to look at the domain of the newly created composite function. For that, we do not want x plus 2 to be 0, so we do not want x to be negative 2. So, in WebAssign, the choice you're going to pick is all real numbers minus the set containing negative 2 and 0. So that's what it's going to look like in WebAssign for the domain. Now we're going to go the other direction, and we're going to find G circle F. This is when we plug F into G. So let me scroll back up here. And in fact, you know what? Why don't I do this? Why don't I copy this and paste it down here so we've got something to work with. Oops. Okay. So here is our problem again. So this time, we are going to take this and we're going to plug it in right there. So we're going to have 6 over x plus 3. All right, now I think I'm going to delete this now that we used that. So to simplify this, let me write it horizontally. So let me say that this is 6 divided by x over x plus 3. So this is the same thing as 6 over 1 times the reciprocal. So I'm going to flip. And there is nothing that I can do to simplify this. So I'm just going to, there's nothing I can cross cancel. So I'm just going to multiply straight across. So we get 6 times the quantity x plus 3 all over x as our answer. Now, just as we did in the last one, we are going to first find the domain of the inside function. This time the inside function is f of x, and its domain would be that I do not want x plus 3 to be 0, so I do not want x to be negative 3. Here is, if you can still see this up here, this is our function f right here, x over x plus 3. And since division by 0 is undefined, that's why we do not want x plus 3 to be 0. Now we also have to find the domain of the newly created composite. Here is the newly created composite, and I do not want x to be 0 because, as you can see, our denominator is x. So that is our domain. In WebAssign, you're going to see all real numbers. So the set of all real numbers, but we want to remove -3 and 0 from that set. Okay, number 7. Okay, so for number 7, first I'm going to find the X-intercepts, also known as the zeros of this polynomial function. And I am going to factor by grouping. It does work for this one. Later, we're going to have to solve an equation where I cannot factor by grouping. But for this one, I can. I can pull out an x squared. I'm left with x minus 3. And then I want to pull out a -9 so that I have x minus 3 again. So my factors are x minus 3 and x squared minus 9, because I make a factor from the binomial that repeats, and then make a factor from the GCFs. Now, x squared minus 9 will factor further as x minus 3, x plus 3. And then I am going to write this as x minus 3 quantity squared, because multiplicity, as we know, is important. And so by writing that as x minus 3 quantity squared, hopefully we'll see that the 0 that we get from setting that factor to 0 will have a multiplicity of 2. Sorry, trying to move this down here. Okay, so to find the two X-intercepts, I'm going to set my factors equal to 0 and solve. I get x equals 3 and x equals -3. The x equals 3 has a multiplicity of 2, because that factor, x minus 3, is squared. So my exponent tells me my multiplicity. This one has a multiplicity of 1. A multiplicity of 2 means a touch, and a multiplicity of 1 means a cross. Now, before I sketch this graph, there's one more thing I want to talk about: end behavior. So if we look at our leading term is x to the 3rd. So we have a positive leading coefficient. We also have an odd degree, but just know that if you have a positive leading coefficient, your graph will rise to the right. So instead of knowing, there are actually 4 cases. But if you know the touching and the crossing, and you've got that correct, anytime you have a positive leading coefficient, your graph is going to rise to the right, no matter if you have an odd degree or an even degree. So I'm going to look for my graph to rise right. All right, so now let's graph this. Okay, it's just going to be a sketch, nothing fancy. In WebAssign, this is actually a multiple choice question for this. But, you know, we want you to support your answers, so you're going to have to show the work that I have above. So 3 is one of my X-intercepts, it's a touch. -3 is my other one. It's a cross. And I know that I want my graph to rise to the right. So I got to have it rise over here. Another thing you'll probably want to look for is the Y-intercept. So let me go all the way back up. It looks like our Y-intercept is way up here at 27. This last number here is going to be your Y-intercept, because a Y-intercept is found by substituting 0 into the equation for x. And so any term that contains an x is going to go away. So Y-intercept is 27. So as I'm graphing, this is going to go all the way up here to wherever 27 is. I'm going to cross over here. So let's say this is 0, 27 way up there. Let me make this a little bit better here. Oop, it went away. Okay, so this point up there is, we'll say 0, 27. All right, so here is a sketch of that graph. All right, let's look at number 8. Number 8, we have a long division problem. Okay. Sorry, I'm trying to move this one down here. For long division, and by the way, I could not use synthetic division for this even if I wanted to, because my divisor has a degree of 2. Okay, the other thing I want to point out as I start writing in this dividend is I am going to enter in a 0x squared. I want all powers to be represented underneath the division bar here. Otherwise, it gets really tough to line up your like terms. Okay, so we start and we look at the first term of our divisor and the first term of our dividend. And we ask ourselves, what can I multiply 2x squared by in order to get 4x to the 4th? And that would be 2x squared, because 2x squared times 2x squared is a 4x to the 4th. Now I'm going to distribute this 2x squared, multiply times each of the terms of the divisor, and write the result below. So we have a 4x to the 4th, because 2x squared times 2x squared is 4x to the 4th, and 2x squared times 1 is 2x squared. I'm going to write that all the way over here under its like term. Okay, now we are supposed to subtract, but an easier thing to do, or at least it seems that students make less errors, is if you change the signs, then you are able to add down. So I'm going to change those both to negatives, and then I am able to add down. So it just seems like students make less errors when they do that. So a 4x to the 4th plus a negative 4x to the 4th is 0. The 6x cubed isn't going to change because I'm not adding or subtracting anything from it. And then 0 plus negative 2 is a negative 2x squared. And then I'll drop down the 5x. Okay, now we're going to do this again. We're going to ask ourselves, what can I multiply 2x squared by to get 6x to the third? And so that would be a 3x. 2x squared times 3x is 6x to the third. Now I'm going to take the 3x, multiply it times each of the terms of the divisor. And I get 6x cubed and a positive 3x. But I'm going to make both of those negative, because if I change the signs, then I'm able to add down. You could also leave the signs the same, but then you would subtract down. 6x cubed plus a negative 6x cubed is 0. The negative 2x squared just gets dropped down. I'm not doing anything to it. And 5x plus a negative 3x is 2x. Now I have to do this one more time. I have to ask myself, what can I multiply 2x squared by to get negative 2x squared? And that would be a negative 1. Now I'm going to multiply the negative 1 times each of the terms in the divisor to get negative 2x squared and negative 1. Now I am going to change their signs. So they're both negative, but I'm going to change them to positive. And by doing that, then I get to add down. So negative 2x squared plus 2x squared is 0. The 2x just drops down. I'm not adding or subtracting anything from it. Negative 7 plus a positive 1 would be a negative 6. It would ask for a quotient and a remainder. The quotient is what we have written up top, 2x squared plus 3x minus 1. And our remainder is what's there at the bottom, the 2x minus 6. It is okay to have a remainder. That is a binomial. Once you get something that has a degree that is smaller than the degree of the divisor, you are done. Okay, you know what? I feel like this video is getting kind of long. I think I'm going to end this video and I will start the next video with number 9.